Okay, so if you guys look at the bottom key down here, it'll say oxidation states. Okay, and we use those for ionic, we use the charges. So you guys can find the charges of everything, right, if they're ionic? Okay, so if I ask you to, do an easy one, like we're just doing ionic, and so we're going to introduce some new things with covalent today, but if I said ionic and I put like K, 2S, you could tell me, yes ma'am, you could tell me the oxidation states of those, right? So what's the oxidation state for K? 1. Plus 1. Is that hard? You guys have done that, a bunch. Okay, what's the oxidation state for sulfur? -2. You done it. You got it done. So you know a lot of this already, if it's ionic. Okay, so what if it happens where it's not ionic? We're going to get into those issues where if it's not ionic. Okay, so here's some basic rules that I need for you to write down. All right, if an element's by itself, it is counted as a 0 because it hasn't gained or lost electrons unless it shows a charge. Okay, so when you say a pure element, they're always 0. Oxidation state's always 0. Pure elements. 0 would be its oxidation state. So on your worksheet, for example, if you looked at number 1 on your worksheet, it said K plus H2O. All right? It said K plus H2O. What would be the oxidation state of K? 0. What's the oxidation state of hydrogen?
2. Well, in that case, 1.
So you look on the periodic table, H is with oxygen, so what would be the oxidation state of hydrogen? +1, right? Because on there, you look at the key and it says it's a 1 or a -1. Well, it's out in front, it's going to be a 1. Okay, and then we'll get into that rule here in a second. What's oxidation to oxidation state? -2. Okay, so later on we'll do what's called redox reactions. We'll talk about them and that. So that's really all you're doing. You're saying this is 0, this is a +1, and that's a -2. So we're just assigning oxidation states to elements. And so if it's a pure element listed by itself, it's going to be 0. Okay? We're going to skip the next one and come back to number 2. All right, we'll come back to number 2. F is always a -1. Okay, fluorine's always a -1. No matter what it's paired with, we say it's a -1. So here's an example. OF2. So what's the charge of oxygen normally? -2. We say oxygen's a -2 most of the time. Then we got fluorine, it's a -1, right? So can they both be minuses? No, they all have to balance out to 0. So in this case, fluorine takes over and it says, you're not going to have extra electrons, I am, and so fluorine would be a -1. So what would oxygen be? +2. Fluorine outrules everything. Anything fluorine is paired with, it outrules it, and it'll say I'm a -1. So we're going to get to this. We're going to get to this scenario where all these numbers. You guys ever wonder why they have all those numbers like 1, 3, 5, 7, 2, 4, 6? They got all these numbers, and you go, well, why do we only use the first one? Well, you don't always use the first one. In ionic compounds, we do. Is this an ionic compound? No. No. Molecular ones are going to be different. You got two nonmetals hooked together. Fluorine is always a -1. Oxygen, usually a -2. Okay? Usually a -2. Not always. We got an example where it wasn't. So pretty much every time you see oxygen, you're going to see a -2. Now there is an exception called a peroxide, but I'm not ever going to include those. Okay? So I'm not ever going to include peroxides, like hydrogen peroxide. Oxygen's a -1. So, but I'm not going to include that, okay? You guys got enough to worry about. So oxygen's usually going to be a -2. Alright? Hydrogen's a +1 when it's with a metal. So H is +1 with non-metal. I think I said metal, but with non-metal. And H is a -1 with a metal. So, like if we have HCl, well, it's with the non-metal, right? So H is a +1, and chlorine's a -1. Oxidation state. Right? So when is it a case where it's the other way around? So we might have CaH2, calcium hydride. So calcium's what's its oxidation state? +2. Now hydrogen, each one's going to be what? -1. Okay? All right. We're going to go back up to number 2. Talk a little bit about that. And then I'm going to give you some examples to look at. And then we may do the lab at that point. And then save our information to talk about. We probably won't know the results or how to do the results. But we're going to go ahead and start. We'll do the lab. Okay? Now the lab, what you'll do is you're going to come up and get enough for your table. You'll probably get about 200 milliliters of this stuff for your table. And we'll have to measure out 20 milliliters of this into 4 test tubes. And that'll take all your time. And then what you're going to do is you're going to add drops into each test tube, mix it up to see what happens. Okay? So we'll do that here, probably about 5 minutes, get you going on that. Right? Okay, number 2. In a binary molecular structure, the element with a higher electronegativity, you guys know what that is, right? You can find that. Is always negative. Okay, so always takes on the negative oxidation state. So let me give you a couple examples. Right? P2O10. Now look at P and O. Find its electronegativity. You got to look on the back side. Okay, oxygen's electronegativity is 3.44. What's phosphorus electronegativity? Okay, so which one's going to be negative? The one with the higher electronegativity is negative, right? So, do you have a backside on yours?
No.
I'll get you one. You don't have one either? Okay. Well, I know on the chart, we use it on the chart. So I'm going to get you guys ones that need to have electronegativities and just double it for you. Okay? So oxygen is a -2. We said oxygen most times a -2. So what's the charge of phosphorus? Positive what?
2.19.
Yeah, but We assign the negative with oxygen. So we'll pick the negative. Whatever the negative's listed, like we do with ionic, we pick it. What's phosphorus? 10 total. Each one's going to be what? 5. It's 5. Questions? How about this one? This one's always interesting because the way it's written, students kind of mess up on it. But we'll do ammonia. Okay, so which one's higher electronegativity? Nitrogen or hydrogen? Nitrogen, right? So what would be its charge? I plugged in the wrong thing. So nitrogen would be what? A minus 3, and hydrogen would be what? Positive what? Positive 1, right? Okay, positive 1. So that kind of breaks one of those rules, saying when hydrogen is with a non-metal, it takes on a certain characteristic in that. So, all right, questions, comments on that? We will do some work with this tomorrow. Okay, I'm going to give you out this sheet. This test is really picky. Sometimes I have to adjust the amounts of drops that I have to have you add. So if you don't have a color change or something doesn't happen, let me know and I'll come back. Now you guys have to wear aprons. You got to wear goggles. It's only for a short period of time. You guys will have to get a test tube rack out and you have to use the large test tubes. Okay? They've got to be clean. So hopefully you got 4 clean ones you can use. Right? Your table will have to come up and get around 200. You just take a beaker, that's a 250 milliliter beaker. Somebody from your table, a group of 4, come up and get 200, and then you can divide that out however you want. Because you need 80 to fill the test tubes up. Right? Then you're going to put your results down here. You won't have to put the manganese oxidation state in there.
So you're just like,
Oh yeah, I was trying to figure it out.
Let me pour that for you. Once you get this divided out between your 2 groups, so you have about 100. So once you come up and get your 200 for your table, divide it in. So both groups will have to get beakers out and test tubes out. Okay?
Do we do it ourselves or does he?
I think he does it. I don't know. I don't trust myself.
You don't want to pour it?
No. I might spill it.
Yeah, this will stain your clothes too if you get it on. As you know, it looks
Why
like
am I
it could
pouring it?
possibly do it. Kind of like grape juice. Looks good though, right?
Ew.
Looks like something you can drink. Just for your table. I don't want both people coming up from the same table because I'm giving you enough that you guys can divide this off into 100 for your table. There you go. You're welcome. Got to use large test tubes. What? You got to use graduated cylinder to measure out your 20. Yeah, you guys got graduated cylinders. Use those to measure out your 20. You guys just one at your table? Okay. There you go. Just one at your table, right?
Also, we don't have a test tube around.
Okay, look on the other side. See if they got it on the other side.
This side?
Yep. There you go. Easy. You can use the large plastic one. Now this is HCl. You're going to have to wait for your next two. Okay?
Yeah, but you're still around it. You're still doing this.
Yeah. I wasn't sure if this is the
Okay.
And I also I feel like it's minute. Literally like cinnamon. We're trying to access
But then there's like different things we get that.
Warm. What the heck was that? Okay, the NaOH will be here. The only ones you can't do, and I'll get that out for you. You can do the second one where it's 8 of HCl and 8. No, you can't do that one. You're not going to do any of them. So you got to wait. Be patient. I'll get you out the last one. I think I should have those mixed up. Yep. You do it that way. So write the color down, test tube 1. That's kind of like your control. Yeah, you're going to have to wait for the other one to come out. So you can add these drops if you want to now, but you'll have to wait until you get the final outcome. It's in AOH. Be careful with that. That's really strong. Yes? What's that? A little bit? Okay, just take a paper towel. That's not very concentrated. It looks like it is. Take a paper towel and then just kind of wipe it. Right, the first test tube, just write down the color. It's your control.
I think so, right? Let me think of it.
Okay, I will bring you around a pipette with the NaHCl3 because I don't have individual ones. So I'm going to give you a pipette. You guys share it on your table. Okay, this is the NaHSO3. You got to share it at your table.
Okay, yeah, we're not doing that. Wait, can I go?
You have to take a...
Where does the...
Yeah, right here. 0, 0. Yeah. You have to take a stirring rod to mix up. Okay? So you got to have a stirring rod to mix it up. I'll come back around and give you guys extra if you need extra. You would just... NaHSO3. Yeah, you can put a rubber stopper on and invert it upside down and it mixes faster. So if you want to find a rubber stopper that fits the top, and then you can invert it upside down. Dude, you're oh, that's the wrong one. Hey, wait a second. I want to use this one. It drops. Should be like a 0 or 1. Turn it upside down. You should have a variety of rubber stoppers you can use. And you can and then write down your color changes. Dude, look at it. Not in here.
Wash it, wash it, wash it.
They also change the color.
Yeah.
You want green? Add another drop. Hey, add another drop of NaHSO3 for, which test tube was that?
Last one.
The last one. So where it says 2, you can add an extra drop and it might turn the color it's supposed to. It doesn't change.
Okay.
The last one.
One more? I was on my fingers. Those ones like kind of orange.
Yeah, put another drop. Did you? Which one was that?
That was
Put a 2. Put another drop in this.
alright.
2. Put a drop in.
I can't tell if it's dropped or it's double drop.
That was a drop?
That's kind of orange, isn't it?
Yeah.
Yeah, put a little more drop in. Yeah, we have to address it. Yes, yes, it's the same time.
Green.
Kinda, yeah.
Like green.
So that was 2 drops on.
That was like 4 drops.
Yeah.
Same. Okay, number 2. Number 2, add like 4 more drops of the NaHSO3.
We have one more this one.
Where is it? 8 drops? NaHSO3.
Oh.
Okay, we're almost done.
No, it's
That one's just gonna go clear. Which one is that one? So add a couple more drops. Add a couple more drops.
That's like Flint's water.
Yeah, dump down the drain. Oh, you guys got good. Now, did you guys adjust your drops?
Yeah.
Okay. Okay, I just.
Semi-cross, the tropics are in
There's
Flint.
one more.
Yeah. One more.
No, run back, run back.
Another cross.
Yep.
There's no jungle. It's just probably clear. So probably a couple more. It's supposed to be green blue. It's supposed to be some.
I'm saying
Bell's about ready to ring. Write your colors down. Green.
You know, question with your hand right in Ricky Bobby.
Yeah, there.
Yep. I think this is orange. Yours must turn clear.
But
Well, let me have your, did you guys write down the answers you took down? What do you guys put down?
We had a few in the second.
No, we had 4. So, this one, you have 4 more too?
Yeah.
And then 2 to this one. 4 more.
Okay, so.
These droppers, they're not. Rinse those all out, rinse your beaker out. I'll take the remaining left in your beakers. You guys get all the card Tuesday. Yep.
Rob's.
Look who it is.
Oh, you know.
I thought we were getting shot.
He usually only things that big is like,
First half.
oh my god, it's a witch's cauldron.
If the person wasn't an idiot, it's like this. Do they even know how to run the transition?
We're not kids. We're just getting finished.
You got like 3 on 1.
Sure, I'm gonna
You stop.
Dumb it out.
Are we good to go, Cole?
Yes.
Take your paper.
Real good guy. Clap back. Anyone have any guns? Kind of recorded on video. It was good. Oh, that is just great.
It's alright. You find a.
In here you go.
Project and pick out or insurance.
Lab project.
Yeah. You just have to find a country and then right there we go.
Oh, and it's all being good old past.
Yeah, it was like 3 times.
There's probably like millions of
That's the thing with certain projects, like in itself it's not bad, but there's something really like required.
really
Like you put it over 3 times. This is well, what I do is I just throw it over twice.
I thought you had already left.
Are you going, my friend? Me?
Yeah, now you don't.
Burn up. What kind of gum is that? Fair trade. Nah. It looks like red hot. Pretty sure. Fresh straight burrito.
While you're sitting there and waiting for things to take place, go ahead and get out your worksheet that was given to you last Monday. You were given a worksheet Monday. Get it out. I think you had enough time to get it done.
You were done. I was like,
Yeah. 13 questions, right? Yeah, something like that.
Yeah, I have a couple left. Damn, man.
There's a chance.
there we go.
I said there's a chance outside.
What?
No.
Did I get lucky?
Don't know what I did to my back.
I have the list of like 37 things.
Dalton, get your worksheet out.
Yeah, I wrote up what's up.
scores 87.
Today?
Yeah, I know. Jared made it.
Way to go, Jim.
No, that's long. I did. I dressed as a boy.
Take the scissors and cut it at the bottom.
You made it like so long too.
I know. Come here, Ben.
I didn't set it right when I started. I'll well, I set the short one about here on, so I probably should put it about it. Oh wait, no, I should have lowered it. I probably should have put the
We're gonna address it, Ben.
Hey, just make sure the small one's like pointing like right at your belly button, because I think I've made it too high.
Okay, we'll do a lab today, and it takes about 15 minutes to do, and we'll look for color changes. And I think we got the drops all figured out, what we need to add to get it to turn out right. Sometimes it's kind of one of those labs that is really picky on how many drops you add, and we got it figured out last period, so usually that's the case. Now it's the other way around.
Oh, dang it.
So try it. But I can't do it. I can't do it.
So why didn't you
Try
go
it
back
at home.
Yeah,
He
Ben.
forgot.
Ben, we're trying to do some chemistry here. Please quit bothering my learning environment.
My dad only had to teach me, okay, he had to teach me like 5 times, but I can
Okay,
twice. I was gonna say once.
I'm just going to write this on the board. I recorded it for those who are gone already. And the way I would approach doing these problems on a test or a quiz, since it's all mixed up, I'd find everything that has the same type of reaction. All right? That's the way I would go about doing it, and so that's the way I'm going to go through these answers. So we'll divide everything up into individual specific types of reactions. You guys have your sheet that has your solubility rules and statements. If they react with acids or water and that kind of stuff, you need that out. If you don't, get it out. Okay. Number 1. Number 1 is water is going to be placed with an element. And off to the side it'll say, these will react with water. Or they won't say anything at all. So K plus H2O, it says off the side, it will react with water. So that is a single replacement that will happen. The K will come in, replace the H. You got KO plus H2. But the K is plus 1 and oxygen's a minus 2, so it's K2O. And then you balance the K. You got your reaction balance. Any questions on that? So what I would do, as long as I'm going along those lines, I would go down the line and I would go ahead and find another one that reacts with water. So I go down to 6. And since I'm on this kick of doing just water, I look at that one and read off to the side and it says nothing about reacting with water. So that's a no reaction. Has to state it, has to say it reacts in a certain way with water. And it doesn't. Okay, go down. What's the next one I go to? 10. And realize that Ca will react with water. And it makes CaO plus H2. So we're good there.
Do you want the H2 like always
Nope. You can put it first, you can put it second, you can write it like this. It doesn't change the outcome.
Okay.
Questions on that part? Makes sense? All right. Then we go up to number 2, and that one is oxygen. So we're going to look at if they form oxides or not directly. So we find aluminum, and aluminum says, yeah, off to the side it will, over a period of time, oxidize. So that would be Al and O go together. And that's the only way it can react. They call this a synthesis reaction because you synthesize one product. So aluminum's a +3, oxygen's a -2. So it's Al2O3. And then this would be balanced. Questions?
What number is that?
2. Number 2. So I'm skipping around. Well, then I'd go to everything that involves oxygen. That way I'm keeping on the same type. So number 4, this does not take place. No reaction.
Is 3 oxygen? Or no, that's the other one. Just kidding.
Okay, number 4. So I'm skipping around. Okay, I'm not going to do 3. It involves oxygen, but it's a hydrocarbon. And it's not on your list. It's not on that list of single elements. So that's the one that you memorize, you produce carbon dioxide and water. But we'll come back to that one. How about 8? Does 8 happen?
Yeah.
Yeah. Cu plus O2 gives you CuO. Or it could be Cu2O, depending upon what charge you pick out. So if you picked it out, you said, I'm going to use the one that's +2 because you really don't know, you put a 2, 2. And then if it's the other one, put a 2, 4, and that would be what you'd have. Questions? Number 11 would be our last one. So 11, Ba plus O2, BaO. And then 2, 2, balance. This is a +2 and -2, so they balance out. Questions?
Wait, why do you need the 2 in
What?
front of the barium?
This one because I got 2 bariums here. I got to balance out my oxygens. And so,
Okay.
yep, I got to balance everything out when I'm done. Always need to do that. All right, now I'll go down and I'll go up to number 3. So now I'll look at that one, and I remember that if you got a hydrocarbon plus oxygen, you always get 2 products out, and they're always the same 2 products if it reacts completely the way it's supposed to. So what are the 2 products you get out? CO2 and H2O. CO2 and H2O. You just write those out. Okay, I get some weird answers on these because students forget to recognize it is a hydrocarbon and oxygen, and they will give me some weird answers because they think they need to try to balance them out right away. So I just write CO2, H2O. Okay. There's not a lot of memorization that you have to do in here. A lot of it's processing the data table and recognizing if it reacts or not, if it's soluble or not. This one you got to memorize. You put a 5 here and put a 5 here and realize that the right side's 15 oxygens. Well, a trick you can do is take that 15 and write it in here. And then everything doubles. 2, 15, 10, 10. And then so you'd have your answer. Be 30 oxygens on the right side and 30 on the left. So next one that would be a combustion is C2H4. By the way, tomorrow I'll probably do this reaction for you, either tomorrow or Monday. If there's a bunch of people, when do you guys go down for your counselors meeting?
First period.
Okay, so I probably won't do it tomorrow because those guys will be, first period will be left out of my class, so. All right. So probably do it on Monday, the day we review. Go through the review. Tuesday, okay? Then that makes CO2 plus H2O. Then we balance. This one's a lot easier. 2, 2, 3, I think. And then number 12, did you guys get that one to balance?
Yeah.
What was it?
2:31.
2 what?
31. 2022.
2022. So the way I go balance it, I put a 10 here, then over here I put 11, and realize on that side I have 20, 31. So that 31 will go up here, double everything. Hey, look how nice that is. I have students that will spend 5 minutes trying to balance this reaction. And if you know some little tricks to the trade, help you out. So if that odd number you come up with, you count it, you can place that right there. And then double everything. And you got it balanced. 2, 31, 20, 22. Okay, the last reaction is like 7, 9, and 13. And these, you got to memorize as well, in a way. It's called a neutralization reaction because it's got an acid and base. How do we know it's an acid? How do we know it's a base? An acid has H out in front, so HCl. And then this is a base because it's got a hydroxide, KOH. They react to make KCl plus H2O.
Those always form waters, right?
Yep,
Okay.
they always form waters. They always form a neutral substance. And that water is that neutral substance. That one's balanced. Next one, acid, H2SO4. NGOH2. So we switch, we make H2O, H and OH go together, make H2O, then MgSO4 goes together. And they're plus and minus 2, so they're fine. A lot of times this tells you what you can put in front of water to balance it out. So I'll put a 2 there. And when I do, it should balance out the H's and the O's. So I'd be balanced. Okay, and then the last one is H3PO4 plus LiOH, H2O, and then LiPO4, phosphate's a minus 3, lithium's a plus 1, so Li3PO4. That free tells me I need to put a 3 in front of that one. And this 3 kind of gives me an indication I can put a 3 in front of that one. And then if I check it out, it should balance. 6 hydrogens and 3 oxygens. And then, I know I went through that pretty quick. You guys should have had that all down. We'll do some more review with that. Tomorrow you'll get the review. Monday we'll go through the review. Like I told the other class, if you've been working on all these worksheets, been paying attention, along the line, doing pretty decent on the quizzes and that, the review is just something you don't have to complete the whole thing. There might be sections that you want to work on, maybe more than other sections. I'm going to give it to you, and then we'll go through all the answers. But sometimes it could be busy work for students. If they know how to balance, then, why go through and do that? But there might be some that are a little bit more difficult to balance on the review that you can practice. Okay? Now, you can put that away for now. Your book below you will have some information that we're going to go through on this last part. Okay? This last part, you need your periodic table out as well. Okay? You need your periodic table out as well. The page is 232. You need your periodic table out. And we're going to take some notes. So if you got a section in your notebook to finish out what we're talking about,